Hello everyone. In this lesson, we will study the last content in NX10 software, drafting, creating an assembly join. In this lesson, we will use the fixed Vise body as an example to teach the process of creating an assembly join. First, we need to understand what content the assembly join should include. The assembly join should contain a general layout that displays the overall content of the assembly. This includes the names and numbers of each assembly component, as well as their positions and relationships. It should also list a detailed parts list in assembly order. Analyzing the entire join, we see that the dimensions length, width, and height of the entire Vise assembly are labeled. A four-section main view is used to express all the internal structures, and an asymmetric view shows the Vise style. An assembly join doesn't necessarily need three views. It only needs to fully express all parts. At the same time, all part numbers are labeled in order, with corresponding detailed information provided. Next, we will explain the commands. First, open the bench Vise assembly file in UGNX10. Then click Start Drifting in the menu bar. The system will pop up a Join Sheet dialog box. Select Use Template. Call the join frame. Set the parameters and enter the drifting environment. Next, add the main view. The main view is a section view, so we need to select the top view as the parent view to create the four-section main view. Select the Section View command. Then click the long axis center line of the top view as the cutting position. Move the mouse upward to place the section view. Be sure to place it directly above. Otherwise, the system will automatically adjust the view's rotation angle based on the mouse movement. Once in position, click to complete the operation and exit the command. After completing the main view, click the top view frame. Set hidden lines to be visible, preferably as dashed lines. This way, you can clearly see that 4 screws need to be sectioned. Since these 4 screws are distributed across 2 parts, we need to create 2 partial sections. Click the Sketch Artistic Spline command in the drafting environment. Draw the 2 cutting positions simultaneously. First, draw one partial section by sketching an artistic spline curve at the screw position. After completing the drawing, click Confirm to exit. Then click the Partial Section command. The system will pop up a dialog box. In the dialog box, you will see highlighted icons and grayed out icons. The highlighted icons represent the current operations to be completed. The grayed out ones are subsequent steps that will be generated after completing the current steps. This must be done sequentially. Select the top view to generate the partial section view. Define the base point by clicking the center point of the threaded hole in the side view. Afterward, define the vector direction. Select the axis direction of the threaded hole. Then click the Join Spline curve at the cutting line. Click Confirm to complete the partial section view. Repeat the process to create the other partial section view. Note that components like the lead screw and nut do not need to be sectioned. Therefore, after creating the four-section main view, you need to remove the sectioning for the lead screw to complete task 2. Click the Section command in the view. Select the completed four-section main view, and find the lead screw, fixed screw, nut, washer, and other components in the Object Section dialog box. In the action bar, select Non-sectioned, then click Confirm to complete the operation. Click the Insert Parts List command. and the system will pop up a dialog box where you can set the cell format. Set the borders to 6 solid lines. Create the table from left to right. Insert the required number of columns. Edit the content of the parts list. Fill in the code, day, quantity, and material according to corresponding serial number. Write any special requirements in the remarks column. Then adjust the size of the parts list to match the size of the title block. After editing, click Confirm to exit the editing, completing Task 3. Creating annotations. Click the Annotation command to add technical requirements. The annotation requirements for an assembly are different from those for parts. Parts require machining accuracy and dimensional requirements, while the assembly needs to express the overall assembly requirements. In the format, set the font size and style. Then add the technical requirements. Enter 2 points. First, the parts must be cleaned and washed before assembly, free from burrs, flash, oxide scales, rust, chips, oil, dye, and dust. Second, during assembly, parts must not be bumped, scratched, or rusted. After completing the engineering drawing, be sure to save it. In this lesson, we learned about the process of creating an assembly drawing for the bench Vise. This concludes our study of modeling, assembly, and drafting in UGNX 10.0 software. Please practice more after class to become proficient in the operation. Goodbye.